recording now, just to let you know. So yeah, welcome again. This is the 9th Zero Knowledge community call. If you haven't met me before, I'm Owen. I'm a DevHub developer relations contributor, and I'm just moderating this call. So if you haven't joined one of these calls before, it's basically just a great way for the community to meet up and discuss zero knowledge in the ecosystem, give updates on projects, and try to shape ideas and proposals are normally first discussed in the zero knowledge community chat more informally, and then they go on to be posted as a more formal proposal in the activity feed on near devhub.org, and I'll drop some links for them later. So the format of these they're mostly free format, but we have some topics of discussion proposed and people giving presentations to keep it nice and interesting. And if you want to speak on a certain topic or give a presentation next time, just drop it in the community channel or reply to one of the tweet announcements. So we had Pedro suggested that we talk about MDC private voting, which we will do later. So participation, we love participation. Make your ideas, your thoughts, your grievances known. And if you want to participate, just speak up. But if you're not comfortable with that, you can just write a message in the chat. And the moderator role of myself is just take notes, encourage participation, and I won't be making any decisions on proposals or ideas here. And if you want to be the moderator for the next call, just let me know, and that can happen. And yeah, this call is being recorded, so we'll post it to YouTube afterwards, so everyone can see. Right, here are the proposed topics for this week. We'll get started in a second, but I just wanted to say, if you have a near repository that's open source, if you could do me a big favor, and Ilya asked for this himself, if you could put this repo on the Electric Capital report, and it just shows that Near has a load of cool projects, and try and highlight the growth of the developer ecosystem, and that helps to attract even more devs into the ecosystem. I'll drop the link for that later, but yeah, if you could do that, that would be a great help. So do we want to get started with vSelf with ZKLogin? Have you got any slides you want to share?
Yeah, I would like to kick it off, start, and then Ilya will continue with the cryptography part to dive a little bit deeper.
Awesome.
Let me see if you see that. So just to remind what we're doing in vSelf in general is we're working on the community service platform. So identity management and the idea how we can provide customer data management and engagement data for more general public than just degen space is one of our key focuses. And obviously ZK is one of the ways how we can try make this type of solution more accessible and more adopted outside of the kind of purely Web3 native space. So one of the things we recently proposed as a mean-based grant and is still under consideration is ZKLogin, which was inspired by SUI analogous tool for their ecosystem. But I was saying is very well connected with everything that we already have in the near space. So one of the key issues that we're addressing here, besides obvious that it's hard to make users sign in with wallets every time you want to provide any Web3 focused dApp for them. It also very hard to justify a lot of even hybrid architectures about customer data from the regulation standpoint when you go to Web2 clients and say, let's use loyalty or social engagement tooling for your customers. That's one of the main questions that we're being asked for. So the solution is to mix the Web2 authorization flow with ZK and generated ephemeral new accounts to kind of merge it together with seamless flow without compromising user identity on chain. So the key features is like chain is fully abstracted from the user side. It doesn't look different from what users are normally using, but we do have some Web3 components without, most importantly, identifiable or later identifiable using data pattern extraction traces on-chain about that Web2 account. So our roadmap from there, we plan to release an open source NPM package. We do some tweaking compared to the existing ones, and Ilya will tell more about why we're choosing bulletproofs and what kind of OAuth tooling we're going to choose for our flows. And next stages is to create Telegram bot to create a sort of authorization service to generate the ZK passes. And later, besides proof of account ownership, some extra features based on soulbound tokens and identity management. So Ilya, pick it up.
Yeah. Hi, everyone again. Thanks, Tatiana, for the intro. So I think the context, it's kind of clear. And here's the concept of how ZKLogin works in principle. We were inspired by SUI, as Tatiana mentioned, and that's a little bit simplified version of their flow. But the main idea behind the ZKLogin is that GVT is still widely used, especially in OAuth flows, but it contains personal information. So what we're going to achieve is to extract personal information from GVT, turn it into ZK proof, salt it like for the security reasons to prevent replay attacks. Yes, JSON web token, yeah. And then any DApp that would like to authenticate the user can verify the proof that we actually have the GVT with the corresponding fields like issuer, audience, and also authenticator can provide public key like GVK for the signing authority that issued original token, and combined with the ephemeral account that we create on the user's demand and store on our servers for the moment. Verifier can actually know that this account was used to sign the payload, and payload is ZK proof that proves the token exists, and it was like valid authentication credential. And that's kind of it. But I want to mention that SUI's implementation uses Growth 16, and it's required to have trusted setup ceremony. So we considered switching to using Dalek bulletproofs, which we have a lot of familiarity with, and it has like Rust implementation, state of art. So we thought this kind of adjustment to the original scheme will simplify things, like raising security bar a little bit. And yeah, thanks, Tatiana, for the next slide. So what we actually were looking to build is some kind of Telegram bot with a Telegram mini app within, which will serve our customer base with this one-time passwords for the dApps. And that is one of the flows we imagined, but I think it can be used for different use cases as well. But we plan to focus on Telegram bot as an initial implementation. Yeah, future development. On the technical side of things, we research a lot WebAuthn protocol, so it looks like it also is a kind of passwordless future that awaits us. So we plan to implement WebAuthn authentication as well, but it's not related to ZK at all. And what is related to ZK is ability to authenticate as a part of anonymity set. So you can actually disclose only your group and not your particular identity. And this we have implementations for this case using bulletproofs. It's like open source. We will be happy to add it to the public repository. Owen mentioned in the beginning. That's I think that concludes my technical ideas for the moment. Tatiana, do you have something to add?
Yeah, I think it's generally like the general use cases are often being discussed, but there are not that many tooling in any of the ecosystems that I know about that fully cover it, that will allow like interaction with the customer data of different kind in these scenarios. That includes eventually participating in crowdsourcing different campaigns where we need to detach the input data with which people join communities from everything that is happening on chain. All the engagement activations that already exist can just integrate the anonymous sign-in from this Web2 private data perspective to continue using whatever they already designed for Discords and Twitters to extrapolate it for communities of Web2 companies or traditional brands. And obviously the next extension, and maybe we need to talk more about the integration with verifiable credentials, because it can be also kind of extended on the wider profile, not just proof of participation in something or proof of account ownership, but also particular features of this identity that you're bringing on the table. And that previous slide where we're talking about the future development, eventually we see vSelf as this identity manager of one of these kinds, focused on loyalty and engagement, but still where we can handle multiple sub-identities, because if you use ZKLogin, then you're going to have different ephemeral accounts for different dApps, and it makes sense mostly for dApps that are not DeFi nature, that are more engagement, gamify kind of things. And then if you want to reconstruct the customer 360 out of that, it's better to have some sort of identity provider who would be able to be trusted with doing so. And that one of the directions we can collaborate in the ecosystem. So that's more or less
Thanks.
it.
Yeah, thank you. Yeah, guys, that's long story short. That's the main idea.
Let me ask you guys a question.
Hi, Pedro. Yeah, nice to meet you again.
Hey, how's it been to you? How's been the experience with bulletproofs that you mentioned?
So far, pretty good. So, I mean, I never compared them directly, and I never benchmarked them yet with Growth 16, but it will happen sooner or later. But yeah, it's pretty compact for our case, and I can compile to WASM, and probably at some point in time near runtime, we'll also be able to run verification on smart contract side. Yeah, I'm not super familiar with the current state of the art, like growth implementations. I think I have to benchmark. But
Yeah, we also
experts. Yes.
Yeah. No, we also had to run away from Graph 16 when we implemented OPAC. We used Splunk due to the because we use the ceremony. Yeah, but I've heard that the bulletproofs is fairly good for like small proofs. So I was curious to know more.
Totally. That's my intuition, but I have to do benchmarking. I'll share with community for sure.
Yeah, and I think a good point here to make is a lot of benchmarking and papers that refer to comparison of different methods are focused on the speed and computation when it comes to big transaction load, and when it comes to signing, it's not that dramatic compared to all the blockchain infrastructure things.
Also, Halo 2 looks super promising because it's like direct successor of bulletproofs, and with bulletproofs we have had great experience so far. So let's our like next object would be Halo, but I don't know. Let's keep an eye on the industry. Yeah. For now, it's bulletproofs.
Hans, did you have a thought or a question? Do you want to go ahead?
Yeah. Hey, everybody. My name's Hans.
Hey.
I'm from RISC Zero. I just was curious about proof generation time, specifically for validating RS-256 signatures. How long does that generally take with bulletproofs on your end?
We have had some demo examples. We do it. I think all the examples run less than 10 seconds on the front end in the browser. So it's good for user experience. It's good. And that's our.
Gotcha. I would definitely encourage you to look at some of the repo examples in RISC Zero. We actually do some validation, though we do require trusted setup for our snark validation, but that's like a second step pipeline. First we produce a Stark and then we move it over to a snark. But we do have job validation along with like OIDC sort of validation and a couple of other hacks to enable this sort of ZK login to bridge, Web 2 and Web 3 together.
Super cool. I will take a look. Can you share the link, maybe? Also, I can look it up myself. Yeah, I've heard of RISC Zero.
And we had a question in the chat as well from Igor asking what implementation of Plonk you were using.
We haven't been using Plonk, but probably it's to Pedro. I mean, I have to redirect it.
Awesome. Any more questions?
No, let Pedro explain about Plonk. No?
Oh, I've shared the GitHub repo, so you guys can check it out, our Plonk implementation. It's fully open source too.
And thanks, Hans, got you also. Thank you very much.
Awesome. Shall we move on then? I will probably
we can. Yes. Please.
Thank you for that. We've got a lot of good things to cover. So I might butcher this name here, but Rushil, I think that's it, from Reclaim, talking about verifiable credentials along similar lines with Reclaim protocol. They gave a presentation last call, but I think we're having a bit more like hands-on and less abstract presentation here. Do you want to go ahead and share your screen?
Yes. Hello. I'm audible?
Yep, great.
Yeah. Thank you so much for giving us the opportunity. I'm Ruchel, and I take care of growth. So I'm not be able to answer some of the technical questions because I think they were answered in the last call. But yeah, happy to walk you through what Reclaim is. And considering we are live on production, would love to walk you through a demo. Is my screen visible?
Yep, can see it now.
Awesome. So, so this is a demo of a Farcaster frame where we are trying to generate a proof of personhood by using Uber as a data provider. So the user here is creating a proof that they have taken more than one ride. You can customize these requirements. It could be 10, it could be 100. And let me just play this. Yeah. So we've worked a lot on the user experience. So as you can see, there are no extensions. The user basically needs to scan this QR code on their phone. What we are trying to prove in the next few seconds is there is no pre-installed app called Reclaim. It doesn't exist. We basically use Apple's app clip that are sort of generated when a user scans this QR code. As soon as this QR code is scanned, we are taken to a Reclaim mini app through the Apple's app clip, and then the user creates this proof. So in this case, there's a CTA which says create proof. They are taken to the Uber's website through an HTTPS proxy. They log into Uber. Let's fast forward this. Yeah, enter the OTP. And then they're basically generating a proof that they've taken 413 rides, this specific number, which is definitely greater than 1. And then, yeah, this takes about less than 10 seconds on a mobile device. The next part is where user submits this. So until and unless this proof is not submitted, it throws up an error once you check the status inside Farcaster. Yeah, it shows up an error, but once the proof is submitted from the mini app, it should show that, hey, this person is actually a human. So this is how, in a nutshell, how it works. Fast forward to show that, yeah, once it's submitted, it has been verified, and developers can check their verification status at the link. Going forward, in terms of data providers, anyone can write their own provider. So we have a developer portal where you can submit your requirements. So we have Aadhaar, which is the national ID of India, Amazon order account, Coinbase email address. So there are multiple things that you can use Reclaim for verification. So you can add your own provider. Developers can come here and add their own providers themselves. Some of the use cases where Reclaim is working. One is a completely decentralized P2P exchange. This is built by an independent team who chose Reclaim for 2 particular use cases. One is for KYC. So they're using Aadhaar, which is Aadhaar is a national ID of India, owned by more than 1 billion Indians. So they use it for KYCing their users. And then second is proof of fiat transfer. So let's say I send someone $10,000 from my bank account, their bank account. So to resolve any transactional disputes and to remove any like screenshotting of these fiat transfers, they actually generate a proof of fiat transfer from bank as a provider. They're going quite fast. They've done around 250K worth of transaction volume since launch. Now this number is closer to 400K. Some of the like other integrations. So we are integrated with EAS, Polygon ID, national like the IRS data for tax purposes. Then Aadhaar, as I mentioned. Some of the dApps want to use Reclaim for utilizing Steam data. for gamers to reward them within their dApps. And then, yeah, this is something, the couple of things that are very interesting that we are getting like a lot of attention for. One is indirect or delegated KYC. So a lot of dApp builders do not want to KYC their users, but unfortunately they are being pressured by the legal team. So one workaround that they are using is using Coinbase or Binance or any centralized service KYC and storing that state. So a user logs into Coinbase or a user logs into Binance, and they create a proof that they're already KYC'd there, so that the end user doesn't have to undergo the entire KYC process on a new dApp. So that's something interesting. And second use case that we are getting a lot of sort of attention is for vampire attacking the Web2 companies. So if I were to start, let's say, a new LinkedIn or a new Instagram, I can basically airdrop users based on their activity in the Web2 platform, which was not possible before Reclaim. Yeah, I think that's pretty much it. We recently published our proof of person paper. I'll share all the details here. Happy to take on any questions.
Can you share that paper?
Yeah, sure. Let me share the link here.
Some awesome use cases there. Does anyone have any questions for Rushil?
Super cool. Lots of applications. Big respect to you guys.
Thank you
Curious
so
about
much.
that. How what sort of what are you proving exactly, like across all of these different services? Is it sort of a uniform proof generation, say for example job validation, or are you doing some sort of TLS?
TLS.
TLS? Okay.
Yes. So we were built on TLS 1.3. The TLS 1.3 has a unique property which allows for a key update function, which is not there in TLS 1.2. We do work on top of TLS 1.2, but the verification takes longer because the data blurb is quite large in nature. So yeah, we leverage TLS 1.2 and 1.3 and then 1.2 as well.
Mad respect. That's nice.
Thank you so much.
Okie dokie. So Hans, do you want to talk about RISC Zero now?
Sure.
Awesome.
Yeah. So I don't really have a slide. I could share you guys some old slides, but first, are you guys? Is everybody somewhat familiar? Heard of RISC Zero or know what RISC Zero is? Well, cool. For those that don't know, RISC Zero is a zero-knowledge virtual machine. It's a completely generalizable zero-knowledge virtual machine. It basically allows you to write any code that can be compiled to the RISC-V architecture, which is most compiled code, and prove the execution of this code in the ZK VM. So that allows you to do quite a bit, right? You can do job validation, you can do TLS validation, you can even run Doom in the damn thing. But what I'm here to talk about today is a light client for Near. And disclaimer, I didn't actually work on this, but Austin did. He's my colleague. I work on some other stuff, but we're both engineers there. But essentially, if you don't know, light clients allow you to sort of verify consensus of a network without necessarily executing the state machine transactions within that network. And we do this because full nodes require, much more compute, much more storage, bandwidth, and it's just unnecessary in a lot of cases. But light clients sort of form the basis of different sort of interoperability use cases, as well as efficient state sync, right? So what we did was design a light client for Near, implement that in the ZK VM, and generate proofs for that. So now, with recursion and composition at RISC Zero, we can recursively prove these light client blocks, and you can efficiently validate the canonical head of a Near blockchain with ZK proofs. So it's a big step. honestly our first step into the light clients kind of space. We're a pretty chain agnostic company. We're based out of Seattle, Washington, in the United States. And yeah, we really hope to just bring generalizable, verifiable computing. So if you're working on ZK proofs and you're running into hiccups with circuit design or complex sort of applications, I would encourage you to look at sort of generalizable VMs. They're super versatile, and we do have the hardware as well as a couple of APIs for like enabling trustless compute in an efficient way. So the ZK Lite client, for every block, I think the proof time is like maybe a minute, which isn't too bad. Yeah, so that's kind of the TLDR. But excited to see what you guys are working on. It's pretty neat. That's all I have.
Cool. Sounds great. Have you also like considered running not Doom, but maybe a large language model?
Yeah, large language models are tough, mostly because so this VM is slightly restricted in terms of it's a virtual machine. So you're restricted by one, the host machine, and two, sort of the general constraints of the actual VM itself, right? Like because the RISC-V instruction set is the constraints, you're pretty limited in terms of like, storage access, network access. So there are some limitations with VM design, right? Like you can't at the moment, right? Like we're working on these things, and with sort of our pause resume kind of cycle that we've recently enabled with recursion, like you can take really large computational steps and prove them recursively and roll them up into a single proof to validate on chain. And the VM produces a Stark, which is, it grows with the size of the execution trace. But we do have a path for going from Stark to Snark. Snarks are constant time sort of validation, right? It doesn't really matter how big the Snark is or what you're proving, the Snark takes constant time to validate. And we do have a pipeline enabled for that. So you can verify things on chain. This does require the trusted setup from us. We use Potion from the PSE, Privacy Scaling Ethereum Foundation. And we generate, these Groth16 contracts that can verify these snarks in 300K gas for Ethereum. Currently, we only support Ethereum for the deployments of this, but we do intend to support many chains. But yeah.
Got you. And so why Starks in the first? Because like it's post-quantum. Because after switching to Snarks, you're losing post-quantum resistance.
Yeah. So Starks were chosen because some of the underlying principles of like the VM just sort of require this sort of scalable proof format, right? Like it just works better with a VM. The details of that, I can't really answer in a couple.
So it's not about post-quantum, just like engineering choices.
Yeah. I mean, building this thing is it's not a trivial task to build a generalized VM. Yeah.
Yeah. I've seen the project for Cardano chain. It's awesome.
Yeah, and it has a lot of applications, right? Like I mentioned, like the JWT validation, or which can be used for a lot of things, right? You got identity, you have login.
Not only consensus can be verified. Lots of business logic as well.
Exactly.
Got you. We'll take a deeper dive into RISC Zero.
Yeah, and if any of you guys have any questions, hit us up on Discord. You can find the link on our website. You can also just shoot me an email at haunts@risczero.com if you want to get in touch. Andre Cashin, I think you have your hand raised.
Hey. Thanks for the intro. I was wondering, you mentioned proof time is 1 minute for a block. On which hardware is this?
This would be Bonsai, and don't quote me on those times. I need to check with Austin specifically. But so we have our own API of a bunch of clusters of GPUs, and our VM is optimized for GPUs. So you can run, you can upload this image, this ELF image, a compiled program to our API, and we'll prove it at request and spit out the proof as well as any of the write-outs from the actual program itself. But this is a cluster of GPUs that is much more efficient than running it on, like, you know, just a normal laptop. That being said, you totally can, but the proof times for that, it's not optimized for CPUs, it's optimized for GPUs. So if you need an API key, hit us up at bonsai.xyz or risczero.com or Discord, and we can hook you up with an API key if you want to test out that hardware. It's trustless, so at least the computation side, right? The API does require a little bit of trust, but we're working on sort of mitigating that.
And what's your pricing model? GPUs are quite expensive nowadays.
Well, we actually do not focus on ML based GPUs, right? Like A100s or any of that. We use standard consumer hardware GPUs. So we have a large cluster of those reserved. And yeah, thanks for posting that link. But yeah, the pricing model, I can't really say, I'm just an engineer there. You'd have to speak with some of the sort of product team for pricing. We're still in the works for that. It's actually a really difficult thing to sort of determine pricing because of the way some of the services that we use for GPUs kind of host these GPUs, you know, keeping them warm versus not, how many, scaling, like it's actually a pretty complex thing. So in the VM itself, we kind of measure things in cycles, right? CPU cycles. But translating that into, you know, a direct, you know, cost for end user blockchains is not an easy thing, and we're actually still working that out. But we do have some pricing models.
Makes sense. I have more questions, so if someone else have questions, please go ahead first.
No, go ahead, Andrei.
Okay. So you mentioned that you aim for generality, like you have the circuit that is working with any Rust or any RISC-V ELF binary. What do you think is the cost of that generality as compared to building a dedicated circuit for near-light client? What kind of speed ups or slowdowns would we expect?
Yeah, so it kind of depends. Right. So generality does involve some overhead, right? Like you do have to consider the rest of the VM architecture when implementing, you know, some sort of program. And there is overhead. Generally, for the time being, most things will incur some overhead. But we do have a lot of acceleration that we're still working on, right? We accelerate like SHA-256 or ECDSA signatures. These things have specialized accelerator sort of precompiled circuits that basically are added at no cost. But when you're performing steps like, say, you know, parsing a JSON file or something, that does incur, that does have some extra cost to it in terms of computational cost. So yeah, there is overhead. And generally, writing a dedicated circuit, though time-consuming and difficult, will probably be more efficient a lot of the time. But we're not really aiming for, you know, peak efficiency. We're aiming for generality.
Yeah, understandable. Also, I think Garvit had ZK late client implementation, like more tailored for the near system. Just to mention, Electron Labs, I mean.
Neat. Yeah, I'd like to take a look at that for sure. One of the things that we try to boast at RISC Zero is like just the speed at which you can sort of develop these things. So the near light client that we kind of implemented was developed in like maybe a week or two. So not very long at all. but I would love to take a look at some other people.
Yeah, I think Electron Labs, it was a year or so. Yeah, so some trade-offs for sure.
Have you tried profiling that Rust code? Sorry, I have more questions. Have you tried profiling this code, or like, did you need to write this Rust code in some very specific way for it to be compatible with RISC Zero, or did you just wrote like straight or copy Rust code from near core for the light client?
So a lot of the implementations are actually written in Go. So we have to sort of copy that over and we currently, Rust is a first-class citizen for our VMs, so we have to port that over to Rust. There are some difficulties with VMs in general. For one, like system clocks, kind of hard. You can't really do that in a trustless way. And randomness is also supported, but there's a limitation to the randomness and entropy of that randomness. So there are a couple of difficulties, but we did get around that.
How do you deal with the bloat in Rust code? Like Rust statically compiles to 4 megabyte binaries, which are quite, I guess, expensive to prove the content of, for example.
What was the question
there? Do you need to specifically deal with the size of generated Rust binaries? Rust is known for generating quite large binaries when compiled because of statically linked nature, and it's a generally standard library does not really optimize for the code size as compared to maybe Go or some other languages.
So we do support the standard library, though, like by default, our option is to disable the standard library. But because that's required for a lot of crates, we do offer that. But it does increase the binary size. But if you can, try to write things in no standard library. That being said, you totally have that option. But it doesn't really matter for, say, Bonsai. There's still overhead, and can't get around that.
Thanks a lot.
No problem.
Great.
Cool. I'll let other people
Awesome. Yeah, I think we touched a little bit on like AI, LLM there. So I think this would be a good way to segue into zero knowledge machine learning. I think Ilya wanted to speak on that a little bit, and other people jump in.
I just wanted to share like my general idea, and I was looking at the Zama AI project just recently, and it's related to the fully homomorphic encryption tech. I don't know, we haven't tried it yet, but I was thinking if you have ideas about using like fully homomorphic encryption, maybe you have used it in your projects, guys. And I can do a quick recap of the idea of technology. So like with zero knowledge proof, we can do some magical things like extract personal data from credentials. With fully homomorphic encryption, as I understand, it's possible to run computation on the ciphertext and then produce the result as a ciphertext as well. So it looks very, very promising in terms of privacy, like Big Brother looking into your data, but now it can by design, and that's in my mind creates a big opportunities, like in general. But I'm not really familiar with the current state of the art. Also, I think Zama AI is a good example. Yes. My short take on the field. Yes. Who wants to share? Also,
So we we were actually looking at Zama here at Hackachain, but not specifically for AI. But we've been bumping into a problem called shared private stage or common private stage. And we were looking into it to kind of try to fix that issue. Like, how can we actually execute private computation on a shared stage? And we looked a bit into them, read the docs. João or Jasso from Hackachain, you guys might know him. He looked a bit more. So yeah, if you want, I can share his contact and you guys can chat. But it was not looking into AI at all.
Actually, I'm also not looking into AI. It's just the biggest thing in the room. I was also looking for some use cases. Like in the past, we wanted to do privacy preserving tracing, like in COVID times, who met whom at which time. This kind of like pandemic scoring systems. That was my first encounter with the idea of homomorphic encryption. But nowadays, I will reach out to you guys. Yeah, also let's see.
Yeah, just reach us out on Telegram and we can chat more. But the thing we've seen with like FAJ is that like ZK is I will please guys don't get mad at me, is fairly experimental or fairly new for a lot of applications. FAG is even more like how to build an application with that and that people actually trust. It feels like it's a big part of the challenge. So it's fairly but we're looking into it. I think it's promising.
I don't know if people can trust ZK schemes. I'm waiting for NIST, NIST standardization to do some promises for our customers. Yes. Owen, that was I think my pinnacle of my knowledge at the moment.
Yeah, it looks like well, there's a lot of hype around ZKML at the moment. I think it's only going to grow really in the next few months. Should we? I think we.
Yes, exactly. I'm sorry, answering the chat.
Yeah, thanks. Pedro, do you want to hop on to talk about NDC private voting, ZK?
Yeah, sounds good. So I also did not prepare any slides because it's more of like, so this is the near ZK group. So I kind of wanted to bring it to discussion, even though we talk about ZK, I would say like privacy as a whole. It's something that we've been looking a lot here in Hackachain. And we've bumped into a couple of different people or organizations that are talking a lot about private voting. And I wanted to bring it to discussion here. So we've started to look into ways to kind of fix the problem as a whole, like how to provide private voting within blockchain. And we haven't got into like a full conclusion in a sense that like voting is separated into 3 steps. So first is registration, and we can do that with ZK and do private registration. That's fine. Second one is actually the balloting process where you have to deposit that vote. And we can do that too with ZK. And then the third part is tallying the votes. And that is the actual problem that we cannot like find a decent answer yet. But at the same time, I'm not even that sure what is going on with NDC. And Owen, I don't know if you might want to jump in on that too. Like, I'm fairly curious to know if there's anyone on Near or anywhere else actually working with private voting and these 3 steps of the process, like specifically the tallying one to sum up or to add those votes.
It's funny, but I have been thinking about it a lot, like for a year, for the last year since elections, I think. So yeah, tailing part is the most difficult, and I think some combination of homomorphic encryption and threshold cryptography will work eventually. Yeah, but yeah, we have had some ideas how to do this, and actually, I think Blaze was very interested. I don't know if you know the guy.
No, I do not.
From the NDC council. We discussed with him a little bit. So we should reach out once we have some proof of concept implementation. Maybe let's involve Zama AI for this.
We thought about, oh, there you go, Hans. We looked into a possible solution scheme.
Because it will be like public good for the ecosystem, like in my opinion. Because public voting was a mess, you know, lots of scandal, lots of hurt feelings. And lots of violation of human rights in the legal sense.
Yeah, exactly. And go ahead, Owen. Sorry.
I think to add a little bit of context, I think the best person to reach out to regarding this would be Alex. I'm not sure of his last name, but he's head of ops at the NDC, and it is within, they do have some budget allocated to this in their priorities. And we have Chloe here, who I believe is in House of Merit. Maybe you can add any more context if you do. And I've just seen that they're actually looking for a dev with knowledge of zero knowledge. So it may be along those sort of lines. I've just dropped the link for the job advertisement in there. But yeah, there's some gigabrains in this call right now and in our zero knowledge community. So we definitely need you guys involved with the voting system for sure. That's my thoughts on it all.
Pedro, go ahead. Thanks, Owen.
Like what I've been thinking a lot is like, it's fairly hard to find a solution that works only using NEAR or any other specific blockchain. The best, and please guys don't hate me, but the best case that we found so far is using TEE to actually add the votes. So you kind of do like registration and balloting with ZK, and then you use TEE to add it and destroy the machines. But then again, it's TEE, and I know that there's like a lot of hate with it. And we can't like think of anything that would actually work solely within a smart contract, you know?
I also can't imagine like it's not being a hybrid, at least several steps scheme. And also let's consider using RISC Zero for some kind of tailing, maybe.
I did post a link to one of the examples that we have for a voting machine. We've tested this out with like DAO voting before, and yeah, it's mostly for tallying. And this is actually quite relevant to my experience in the past. I used to work at Gitcoin, which is fundamentally based on this like concept of kind of voting with tokens in a way to distribute pools of money. And there wasn't a good solution at the time, but I think this voting example should point some groups in the right direction.
Thanks, Hans. Super cool. Yeah, looking into it.
Yeah, appreciate it. And I'm not with NDC at all, like not involved with NEAR at all. I was just interested in the private voting part.
Yes.
But also, Owen, that was my take on it. I don't have anything else to add.
Yeah, thanks, Pedro, for that raising this thing.
No, I only have a lot of NEAR swag from last NEARCon. because it was last NearCon. We went there and it was like the event was finishing and everyone had a lot of swag to distribute, and there was no one there. So I got a lot of t-shirts. So if anyone also wants a lot of Near t-shirts, I have like about 100 at home. I don't know what to do with.
Interesting. We will consider.
I think that's us all. Like, we're going to ETH Denver. I'm not going to pack any t-shirts, no socks, because I know I'll find them all there. Free.
Definitely. And Owen, Hafa from Hackachain will be there. I think you guys met on NearCon last year. I don't know if you remember. Also has like long hair. I'll let him know that you'll be there.
Oh, awesome. Is it blonde hair?
Oh no, that's João.
Right. Yeah.
It's like
for sure.
black
for sure.
hair, like really, really dark.
Cool. Yes, and Seth, to answer your message in the chat, I think it's like a priority too. But the NDC seem to want to fund an implementation, right? But I couldn't see any sort of like research be funded really around this. But yeah, I believe there's some budget in there, and I think if you want to do something, I would reach out in the DMs first to the council and this Alex guy. I'm happy to put you in contact.
Alex from Aurora, you mean? Alex
No, not Alex from Aurora. Alex, head of ops. Go ahead, Chloe. Go ahead.
Yeah, sorry, just to add a little bit more context. So the head of it's called NDC Ops, like NDC Operations. They work on the governance framework and some of the other technical details for voting and elections. And it's Alex Bazzato, so Alex B, and he'd be the best person to reach out to. They are looking to hire someone to help out with, for example, like someone with a ZK background, Rust specific, to help out with like the DAO upgrades as well. As other eventual privacy, like private voting implementations as well. So, I mean, as a House of Merit member, I am on the House of Merit. Personally, I am also looking to try and get privacy added. Obviously, it might be in stages, but still, I think from the many members of the House of Merit are looking to like, how do we get to that point where Near is the place where we can invest into and have a place where private voting is like the norm. So yeah, just to add some more context.
Got you. So Alex B. Yeah, that's the right contact. Got you.
I think it might be good to spin up like a group chat with all the ones interested in participating and get some ZK.
If you could do this, would be super nice.
Yeah, I'll have a look about it. Yeah, I see we've gone past the hour here, but does anyone have any more topics they want to discuss, or should we wrap it up there? Okay, I think that's it then. Okay, yeah, thanks everyone for joining in, and I wish you all the best. I'll drop some more links in the Zero Knowledge channel regarding this, and I think more people wanted to hear about RISC Zero, so if you could drop some links as well, Hans, that would be great. Are you in the Zero Knowledge near Zero Knowledge chat?
No, but if you could drop a link to that, I'll gladly join.
Yeah, sure. Well, I dropped some links earlier, but I'll drop them all again.
Oh, I see it. Sweet.
I'll drop it for the benefit of everyone. Yeah, the community page and the Telegram is on there. Awesome. All right. Thanks, everyone. Great to see you.
Thanks, everyone. Have a great day.
Thanks, everyone.
Evening. Bye.
Goodbye.
Thanks, everyone.
Bye-bye.
Bye-bye.
My pleasure. Cheers.